Good morning, students. Welcome to SRPS Online Studies. Today we are going to start our class 7 chapter Acid, Base and Salt. Okay, students? So now let's start. What is acid? Yes, students, you all over you have to know about that acids, that what is that. So here we are going to discuss about some characteristics of acids. First of all, our characteristics in acids are: acids are sour in taste. It produces H plus ion, it means hydrogen ions it produces, turns blue litmus into red one. Acid, when it combines with metal, salt and hydrogen gas, it conduct electricity and are corrosive. It is in the form of acid rain. Okay, and when we are talking about the pH, that's our acid's pH is less than 7. Okay, so when we are talking about the characteristics, so we can say that that acids are sour in taste. Okay, it produces H plus ions, and its main characteristic is that it turns blue litmus paper into red one. See students, here some examples of acids are given. Vinegar, it is also an acid. Lemon juice, it is also one example of acid. Orange juice, curd, tamarind and amla, black tea, apple juice, unripe mango and grapes. These are the examples of acids. Now let's know about some acids. What is about the acid? See students, in curd, lemon juice, orange juice and vinegar, we know that all these have a which type of taste? That is sour. So these substances taste sour because they contain some of the acids into it. The chemical nature of such substance is known as acidic. Okay, and so the word acid comes from where? That word acid comes from the Latin word acere, which means sour. Okay, so you have to remind it that the acid words come from the Latin word acere, and which means that the meaning of this word is sour. So the acids in these substances are natural acids. Okay, students. So when we are talking about the acids, you have to know about some examples of. Now, here some of the acids are given here, and where they have found either some of the specific things that they had given you. See, in our stomach, when we are talking about our stomach, in our stomach hydrochloric acid is present. When we are talking about the car batteries, in that sulfuric acid is present. When we know about some explosive things, that it is in nitric acid is present. In vinegar, acetic acid is present. Carbonic acid, soda is in soda, carbonic acid is present. Phosphor flavorings, we can say that flavorings, common acids, in that phosphoric acid is present. In ant sting, formic acid is present. Okay, and lemon and oranges, citric acid is present. In curd, lactic acid, spinach, oxalic acid, amla, citrus fruits, in that ascorbic acids. Okay, and tamarind, grapes, unripe mangoes, in that tartaric acid is present. See student, this one table is very most important for you, because so many MCQ type or very short type answer is to be coming from these type of table, that which acid is present in this subject, in these substances, and so you have to know about that all these type of acid that where they found in. Okay, understand? So you understand about the acid, that what is that. So in that part we discuss about the characteristics of that. In the characteristics of acid, we know about that its pH is less than 7, its taste is sour, it turns blue litmus paper into red one. When it combines with the salt and hydrogen gas, that it form in the it can form the corrosive in the form of acid rain. Okay, so these are the example characteristics of acids. After then we know about that what are the examples. So we all know that these are the examples of acids, you know. Okay, so the acid name is comes from the Latin word acere, which means this to sour. Okay, and these are the acids where they have found in. Okay, now Now we are going to start our base part. Same as they are of acid, base have some characteristics. When we are talking about the base characteristics, base have bitter to taste, okay, and soapy to touch. When we touch it, it feels just like a soapy. Water soluble base are called alkalis, and all alkalis are bases, but all bases are not alkalis. You have to keep it in your mind. Student, this one is the most important point, that water soluble bases are known as alkalis. So we can say that all alkalis are bases, but all bases are not alkalis, okay. It turns just opposite of the acid, it turns red litmus paper into blue one. And when we are talking about the pH, acid's pH is less than 7 and base pH is above than or greater than 7, okay. Now some examples of base. We can take the examples of base, that first one is detergent, second one is baking soda, drain cleaner, antacid base, ammonia soaps, hand dish, lime water or milk of magnesium, okay. Now about some base. Baking soda tastes sour. What is its taste? Since it does not taste sour, it means that it has no acids in it. It is bitter in taste. If you rub the solution between fingers, it feels some soapy on touching are known as base. Okay, so it means that when you are rubbing any base substances in between your fingers, so you feel some soapy touch. So the nature of such substance is said to be these type of substances. We can say that the nature of these type of substances is known as basic. Okay. Now name of the base and where they found in. Okay. Now when we are talking about the soaps or drain cleaner, in that sodium hydroxide is present. When we are talking about antacid, magnesium hydroxide is present. In antacid deodorants, in that aluminum hydroxide. In lime water, calcium hydroxide. Window cleaner, ammonium hydroxide. Milk of magnesia, magnesium hydroxide. Ammonia, common base, ammonium hydroxide. Okay, so these are the bases which is found in these type of substances. Okay, now weak versus strong base. We know that in acids as well as in the base also some weak or strong base is there. So when we are talking about the weak base, so weak bases are potassium carbonate, okay, and sodium carbonate and ammonia. And strong, when we are talking about the strong bases, sodium hydroxide, sodium phosphate, barium hydroxide, calcium hydroxide. Okay, so these are the strong bases. Now indicators. Okay, students, have you know about the indicators? Indicators. So in that part, we first of all going to discuss about natural indicators. See student, what is the meaning of natural? A natural word comes from nature. It means that the indicators or the indicators which we found from the nature, that is called our natural indicators. Okay, in that part, first of all, our topic is litmus, a natural indicator. It means that litmus is what? A natural indicator. Okay, so what is that? Let's see. The most commonly used indicator is litmus. It is extracted from lichens. It has a mauve or purple color in distilled water. When added to an acidic solution, it turns red, and when it added to basic solution, it turns blue. It will in the form of solution or in the form of strips of paper, known as litmus paper. Generally, it is available as red and blue color of litmus paper. Okay, thank you. Yes students, good morning all of you. So in the second part of acid, base and salt, we had already discussed about natural indicators. So now, we know about the litmus, that litmus is natural indicator, and what we have to do, what color they have to do given by the base. So when we see that if they have to be added to an acidic solution, it turns blue into red, and when it turns into the base solution, it turns red into blue. Okay. Now after that, some examples of indicators. So students, one is of litmus paper is there in natural indicator. Second is turmeric, You all know about turmeric, China rose, that flower also you have to learn it. And fourth one is phenolphthalein. Okay, so let's see what is that, what you have to given the reactions. Now students, this one is our table. So in this table, sorry, in this table what they do, so here in this table they are giving you the reaction with indicators. Set what type of indicator, what they give the color in the form, in the presence of acid, in the presence of base, and what they do in the neutral color. So students, let's see. In our table, first one is our phenolphthalein. Okay, that one is one of our indicator. Okay, so when we added some phenolphthalein indicator, some drops into some acid, so what happened? What color they gave? It means that the acid can't change into any color, so it is colorless. In that part, neutral color, when we had a neutral, what is that neutral color is there? Faint pink. Okay, and when we added some drops into the base, it gives dark pink color. Okay, so when we are talking about the phenolphthalein, in the presence of acid they give colorless, and in the base they give dark pink. Then bromimethol blue, it means that in the presence of acid they give yellow color, and in the presence of base it gave blue color. Litmus, in the presence of acid it turns blue into red, and in the presence of base it turns red into blue. Okay, so these are the indicators table. Now students, here we are going to discuss about the types of acids. See students, as well as the base, we know about that in the base part also we know about some weak base and strong base. See, in this part, types of acids, we see that the acids are divided into two parts. First one is organic acids and the second one is mineral or inorganic acids. Let's see first of all organic acids. Acids that occur naturally are called organic acids. Okay students, organic means naturally. So whatever the acids we have found in the naturally, or so we can say that it is organic acids. And see some of the example of organic acid. Citric acid, it found in lemon and orange. Tartaric acid in tamarind and grapes, and lactic acid is in milk. So these citric, tartaric and lactic, these all are the organic acid which is present, occur naturally. They are known as organic acids. In the next, say that in the next part, in mineral or inorganic acids, acids that are prepared from minerals present in the earth, they are known as mineral acids. Okay, so what is the example of this one? Sulfuric acid H2SO4, hydrochloric acid HCl, and the nitric acid is HNO3. Okay, so this is a basic difference between organic acid and mineral acid. So we know about that organic acids can occur naturally, and the acids that are prepared from minerals, they are known as mineral acids or inorganic acids. Okay, now students, one more topic is there in this chapter, that is neutralization reaction. See student, neutralization. What is the neutralization process? The reaction between acid and base to produce salt. The reaction between acid and base to produce salt and water, that is called our neutralization process. See in the equation form how you have to write it. Acid plus base, it gives salt plus water. So in neutralization reaction, a new substance is formed called salt. Okay, and salt may be acidic, basic or neutral in nature. Okay, so this one is our neutralization. Understand students, what is neutralization process? When acid and base, when they combine together, they can form salt, and they can give salt and some water. So they are known as neutralization reaction. See some examples of neutralization is there. Hydrochloric acid, that is HCl. So when it get react with sodium hydroxide NaOH, so what they give? NaCl plus H2O. Okay, so that one is also one neutralization reaction, neutralization example. It means that HCl plus NaOH gives NaCl sodium chloride. Okay, that is salt and plus water. In the process of neutralization, heat is always produced or evolved. Okay. The evolved heat raises the temperature of a reaction mixture. Okay, so it raises the temperature of the reaction. Now we have to know about that how the neutralization has to be or we can say that how they take place in our daily life, neutralization reactions. So first of all, we know about some in our indigestion. See students, our stomach contains hydrochloric acid. We all know about it. It helps us to digest our food. But too much acid in the stomach causes indigestion. So to relieve from the indigestion, what we are doing, we can take milk of magnesia. So the milk of magnesia contain magnesium hydroxide. It means they have some basic into it. So this neutralizes the effect of acid. Okay. See in the case of see the antacids they had given you. So acid stomach contains and medication enters stomach. What happened after the neutralized stomach contents? Okay. So this one is our first neutralization daily life example, that is in indigestion. So if we have indigestion process, so we can take a milk of magnesia, so it neutralizes the effects of acid. Second is ant-sting. See students, so many times we see that the sting of ant contains formic acid. So so we have to know about this one is our main important question, that the sting of ant contains formic acid. So many times the question is arising in just that which acid is present in ant sting. So you have to know about it, that the sting of ant contains formic acid. It means that when ant bites, it releases acid into our skin. This causes itching and irritations. This effect can be neutralized by rubbing moist baking soda, or we can say sodium hydrogen carbonate. It means that any ant bites you, it means that you have to rub some baking soda over it. So what they happen? So this can also be neutralized by calamine solution also, which contains zinc carbonate. So if we are rubbing any sodium hydrogen carbonate or baking soda or any calamine solutions over it, so we get relief from that. So second example is in the form of ant sting, we can take is calamine solution. Third example in the daily life of neutralization is soil treatment. Much use of chemical fertilizers make the soil acidic. Plants did not grow in much acidic or much basic soil. So what the farmer do? So when the soil is too acidic, it can be treated by base like quicklime or calcium oxide and slake lime calcium hydroxide. Okay, and if the soil is basic, at that time the organic matter is added in order to make it neutralized so that the plants can grow. Okay students, so you know about that. If our soil is too acidic, we can add quicklime or slake lime, and if our soil is basic, in that part we have added some organic matter. Fourth example is our factory waste. The waste of factories contains acids. You all know, if they are allowed to flow in water bodies, the water become acidic and many aquatic plants and animals may be died. So factory waste is first neutralized by basic substances and then waste is thrown into the water. This may not make the water body acidic in nature. Okay students, now our next topic is acid rain. Good morning students. Yes, in part 3 of acid, base and salt chapter, we are going to discuss first of all about acid rain. See students, in acid rain, which two word is coming? Acid and rain. You all know about acid, that what is that, and rain you all know about it. So let's see what is acid rain. The rain containing acid. Understand student? The rain which containing acid, that is called acid rain. So the rain becomes when carbon dioxide, sulfur dioxide, nitrogen dioxide dissolves in drops of rain to form carbonic acid, sulfuric acid and nitric acid. So these type of rain causes damage to houses, historical monuments, to trees also. So many substances over on the land. Okay. So what is acid rain? So the rain which contains higher level of acid, that is called acid rain. And in acid rain, which gases is responsible? Which gases there? Sulfur dioxide, nitrogen dioxide, or we can say that carbon dioxide. They all are the gases which comes in the form of acid rain. See student, by this diagrammatically representation of acid rain, you can understand the things. See student, what is that? Factory is there, okay? And the factories can acidic gases released into the atmosphere. So factories can release out sulfur dioxide, nitrogen dioxide or carbon dioxide in the nature. So these gases are carried upwards by the wind, and these gases combine with water droplets to form acids, okay? And when it comes to our earth in the form of rain or acid rain, so what happened? Acid rain destroys plants, pollutes water sources and soils, and erodes buildings also, okay? So by this diagrammatical representation, we can understand acid rain. Okay students, so this is our end of the chapter. Have a nice day.